Our task now is to look at the system of equations ax is equal to b from a new perspective. Take, for example, this augmented matrix here. So it's a system of equations, three equations, four unknowns, which can be interpreted under this new point of view as, well, a linear combination of the columns is equal to the b vector here. So, from this perspective, the old one, we are seeking the vector x that when multiplied by the matrix A here gives me the vector b here. However, from this perspective, we are seeking the numbers x, y, z, w such that when I combine the columns, vectors here, give me the column here, the b column. Previously, we used the elimination to simplify this system of equations. And what we end up with is this system here, where we see the pivots here, where the independent columns lie, and the dependent columns are the remaining ones, which can be constructed from the pivot columns. Also, within this is the old perspective of the simplified system, but the new perspective is this one. We are seeking x, y, z, and w so that when I combine the columns of the matrix gives me this b prime vector, 1, 0, 0. So the idea is that elimination gives me an equivalent system to the old one. And so the solution x, y, z, and w to this system is the same as in this system, meaning the numbers that combine these columns to give me 1, 2, 3 are exactly the same numbers that I use to combine these columns and give me 1, 0, 0. The reason why this new perspective is so important is because it makes it clear something that might be not obvious from the old notation. For example, if I want to combine columns to give me this vector, then that means that this b vector here must be somehow dependent from these columns here, meaning it can be constructed. And what we are seeking are the numbers that construct this vector. This is very, very important idea. In other words, what this means? It means that our b vector here, this is b, it means that our b vector must belong to the column space of A. Remember, the column space of A are every parcel is the space that results from the combination of the columns, every possible combination. So B must be inside that space so that I can find the right combination, meaning the right x, y, z, and w that creates this B here. So this is very important. If there is a solution to this system of equations here, from this perspective, if there is an x when multiplied by A gives me the vector B, from this perspective means that B, for that solution to exist, B must be within the column space of A. From this simplified system here, the same observation can be made. If I seek x, y, and z, and w that combines these columns to produce 1, 0, 0, then, well, that means that our b prime is this vector, the simplified version of b, the simplified b must belong to the column space of this matrix here, which I'm going to call A prime. It must be that. Otherwise, there is no possible x, y, and z, and w that creates this vector. Well, from the old perspective, that corresponds to saying that the column B here, this is A, the column B is not adding an independent column when I augmented. You see, when I have A and I augmented with the B cannot be independent from what I add. And therefore, the rank of the system A did not change when I append B, because B, by being dependent on the columns that I add, does not add a new pivot. you can see it here. The system A prime here, the matrix A prime here, has just three pivots. But when I append B prime here, well, there is no new pivot. The pivot, if it existed, would be here, so as to make this column independent from the others. But it is not. It is independent, and that's a good thing. It's a good thing that this is dependent on the others. So the idea that B belongs to the column space of A is the same thing as saying that the rank of A is equal to the rank of the augmented matrix with a B. B does not introduce a new pivot. It's dependent on the columns of A. Similarly, the rank of A prime R is also the same as the rank of the augmented matrix. No pivot is introduced by augmenting with B prime. So you can now see that this statement and this statement here are essentially telling the same information, that B somehow depends on the columns of the matrix. And therefore, there is a solution to it.